equations in integral form. So these are all the derivations of different equations. See that how the Maxwell integral form. So in the integral form is analogous to the Newton's equations of mechanics. So Newton mechanics, we know that in 11th standard we studied the Newton mechanics. So the same thing, what are all the equations having the Newtonian mechanics, the same equations are available in the Maxwell equations of the also. So these two equations are analogous. Analogous means same. So the two things are same. So Maxwell explained the behavior and property of the charge, and when the charge is flowing through the conductor, it's called current. So he explained the charge, current, electric field, and the magnetic field. So the differential form of equation is beyond that level of the higher secondary student. So it is very high level. So it has the curl of a vector or divergence of a vector. Curl and divergence is for higher secondary class, not for higher secondary classes. It is above the level. Okay. So we are not going to study about that. Only we are going to see that what is the four laws of the equation, and see that first equation. So here this is called Gauss law. In this Gauss law, the closed integral of E vector dot dA equal to Q by epsilon. That means that E vector is the electric field. By integrating that electric field, you will get the charge is available in that place, and it is divided by the epsilon permeability. So it's called Gauss law, where Q is the charge, epsilon is the permittivity of the medium. Here the charge is in the place that placed or located in any place, it's surrounded by the electric field or the electric flux. So that electric flux starts from the positive charge and terminate in a negative charge. So the electric flux always it starts from the positive charge, and it terminates in the negative charge. That electric lines of force never intersect. So the lines of force start from positive charge to negative charges are never intersect. So it is a continuous path. So that is a continuous path. It is not never intersect. So isolated positive charge or negative charge can exist. So that is the first equation. Explain that first equation. So this is the Gauss law. So we are going to study in that law in a first class. Okay. Second one. Second equation has no name, but the law is similar to the Gauss law. In electrostatics, the law is called as Gauss law in magnetism. That was not in the screen. That is closed integral of B vector dot dA vector is equal to 0. That means that equation implies that mad lines of force from a continuous closed path. Okay, so no isolated magnetic monopoles exist. So that is the second law. So closed integral of B vector dot dA vector equal to 0. It has no name. So it means it explains that no isolated magnetic monopoles exist. So that was explained by the isolated monopole. Monopole means it's a single pole. Exists. So that was explained by the second law. And third one, see that it's in the screen. This is called Faraday's law. So here Faraday's law, closed integral of B vector dot dl vector is equal to minus d by dt of phi b, where phi b is the magnetic induction, E is the electric field. So already we studied that law. So electric field is changes into magnetic field. Magnetic field is changes into electric field. So here the Faraday's law explains that when we change the magnetic field, that is d phi b by dt, rate of change of magnetic flux or the magnetic field. So this law relates the magnetic flux and the magnetic field to the electric field. Here we are changing the magnetic flux. By changing the magnetic flux, electric field is produced. So that was explained by the Faraday's law. So by the Faraday's law, we are producing the electromagnetic induction. That's why we are using that electrical energy supplied to our houses from electricity board by using the Faraday's law that is electromagnetic induction. So that's the basic principle of producing the electricity. So from the Faraday's law, we produce the electricity. Then next one, that is the last law, that is called fourth law. That law is called Ampere-Maxwell's law. So Ampere-Maxwell's law. Here Ampere law, you know that integral closed integral of B vector dl vector equal to mu naught into I. So up to this it is called Ampere circuital law. So this Ampere circuital law is converted into Ampere-Maxwell's law. So Maxwell add the another one term in this equation. So here that IC, that is I enclosed, is called conventional current. then it will indicate the conduction current, and the remaining portion of the equation is indicating the displacement current. So sum of the conventional current and displacement current is equal to a closed integral of v vector dot dl vector. Here you are changing that magnetic the induction. You can produce the electricity for Faraday's law. In Faraday, from Maxwell's law, by varying the electric field, we can produce the magnetic field. So that was the Ampere law. Here, small correction is done by the Maxwell by adding the small the displacement current. So it is changes into Ampere Maxwell's law. So it's a very important thing. So from this equation, we are aware of that the electromagnetic waves existed, and the entire communication system in the world depends on the electromagnetic waves. In fact, our understanding the stars, galaxies, planets, etc. come by analyzing the electromagnetic waves emitted by these astronomical objects. So that means everything is emitting the electromagnetic waves. You know that what are all the electromagnetic waves and how we are using the electromagnetic waves in 5th lesson, 7th lesson, 8th lesson, 9th and 10th lesson. Okay, so now we are going to see that electromagnetic waves. Next topic is electromagnetic waves. See here, that electromagnetic waves is called electromagnetic waves. How that wave is seeing that? See, is electric field and magnetic fields are perpendicular to each other. It's moving in a perpendicular to the propagation of wave. So this is called electromagnetic waves. Okay. In this electromagnetic waves, see that one field is electric field. That is it is passing through the y-axis. That's called electric field. And is that this x-axis? X-axis, that's not x-axis. Z-axis, it is magnetic field. These two fields are perpendicular to each other. These two fields are perpendicular to the propagation. The propagation in that x direction. So this wave is nature of this wave is transverse waves. So electromagnetic waves are non-mechanical waves. So non-mechanical waves. In non-mechanical waves means you know that it is propagating through the vacuum. It does not require any material medium. Thus, that kind of waves are called non-mechanical waves. So we are going to see that how we are going to produce the electromagnetic waves and what is the property of the electromagnetic waves. Okay. Properties of electromagnetic waves. First property of the electromagnetic waves. The electromagnetic waves are produced by the accelerated charges. That means accelerated charges. Charges, you know that when the charges are accelerated, the electromagnetic waves are produced. Here, electromagnetic waves do not require any material medium of propagation. That's why it is a non-mechanical wave. Suppose it's a mechanical wave means it needs the medium. Otherwise, it won't propagate. So it does not require any material medium. So it's called a non-mechanical wave. Then electromagnetic waves are transverse in nature because the particles are vibrate perpendicular to the propagation of wave. So you know that what is the difference between the transverse waves and the longitudinal wave. Here, that oscillating electric field and magnetic field propagating that vector, the direction is perpendicular to the other two axes. That you can see that in animation. Now, the electromagnetic waves travel with the velocity of light. That is c equal to 1 by root of mu naught epsilon naught, where mu naught epsilon naught is the permittivity and the permeability of the free space. So this is in the first and third lesson. We will see that later. So that value velocity of light c is equal to 3 into 10 to the power of 8 meter per second. So property of the wave. Next one is the fifth property. In a medium with permittivity epsilon and permeability mu r. That means suppose it is transferred from one medium to another medium. That is, it is traveled with the one medium to another medium. We can calculate the relative velocity or relative permittivity or relative permeability. So mu equal to c by v, where c is the velocity of light, v is the velocity in that medium. So dividing that two values, you will get that mu equal to root of epsilon r mu r, where epsilon r is the relative permittivity, this is relative permeability. So we are going to relate the velocity of the electromagnetic waves in the two different mediums. So that medium, you can take that any one medium, that is medium is compared with the that velocity of the light in vacuum. So vacuum, velocity in vacuum and the velocity in that object. We can compare that, we can calculate the relative velocity. Next, sixth one, electromagnetic waves are not affected by the electric field and the magnetic field. It is an electromagnetic wave, but it is not deflected by the electric and the magnetic field. Next one is the electromagnetic waves can show interference, diffraction, and polarization. So light is also a form of electromagnetic wave. So definitely electromagnetic waves have the property of interference, diffraction, and polarization. Next one, that energy density, energy per unit volume associated with that electromagnetic wave propagating in the free space. That is energy. Suppose you can consider that electromagnetic wave we are giving that 100% energy. That 100% energy is equally divided between the electric field and the magnetic field. So 50% for electric field, 50% for magnetic field. So here that energy U equal to 1 by 2 epsilon naught E square. This is the energy of electric field. 1 by 2 mu naught V square. This is energy of magnetic field. So like that it is dividing that total energy into two average energy. So the energy density of the electromagnetic wave is U equal to epsilon E square equal to 1 by mu naught V square. So that average energy density for electromagnetic waves. So average energy means same energy, that is divided by 2, So it is the same thing, 50%, it's also 50%. So these two energies are equal. So this is the average energy. So next thing is, have the energy crossing per unit area per unit time and perpendicular to the axis propagation of electromagnetic is called intensity. So intensity equal to the electromagnetic energy divided by surface area. So intensity அப்படிங்கிறது நம்ம என்ன பண்ணுவோம், perpendicular area, that is crossing per unit area, that perpendicular area divided by the surface area. So power by surface area is the formula for finding the intensity I. Next thing is 11th point. Like other waves, electromagnetic waves also carry energy and momentum. Electromagnetic waves of energy epsilon, it's not a U, epsilon, propagating with the speed c has linear momentum, which is given energy equal to epsilon by c. The suppose excited with electromagnetic wave on unit area or surface area is called radiation pressure. So that electromagnetic waves also has the momentum and energy. It can transfer the energy, it has momentum. So here the power equal to energy per speed or epsilon by c. So this is called surface. This it's called radiation pressure. So radiation pressure equal to energy per speed or epsilon by c. Next one, if the electromagnetic wave incident on the material surface is completely absorbed, then energy is delivered is epsilon and momentum imparted on the surface p equal to epsilon by c. Then if the incident electromagnetic waves energy epsilon is totally reflected, so this is the energy of the electromagnetic wave. See, completely absorbed means so total energy is absorbed. So there is no reflection. So this is the total energy. That is P equal to epsilon by C. It's the energy of the electromagnetic wave. Suppose that wave is reflected. See here, if the incident electromagnetic wave of energy is totally reflected, so this is the energy and is the reflected energy. So it has a negative side. Negative side indicates that this is a reflected energy. So we are subtracting that. So negative become positive. So the momentum delivered from the surface delta P equal to 2 epsilon by C. So this is the reflecting energy. Suppose it is completely reflected without absorbing the energy, electromagnetic energy. So it will become two types. Next one, the rate of flow of energy crossing unit area is known as Poynting vector for electromagnetic wave. So the Poynting vector, other things are in a higher level, not in a level. Only you can memorize that equation, that's all. That is S equal to 1 by mu naught E vector cross B vector. So it's called Poynting vector. So E is the electric field, B is the magnetic field. So cross multiplication will give that value of Poynting vector S vector. Or you can write that equation like this, C square mu naught. Because P is equal to 1 by epsilon naught by mu naught is there. So converting that, instead of mu naught, you can write C square mu naught. Substituting that value, you can write C square mu naught E vector cross B vector. So this equation is derived from the which formula? See, you can hear that formula, another one formula is here. See here. So C is equal to, before the one formula. When you put C square, this will become 1 by epsilon naught mu naught. Or mu naught equal to, you can take out the epsilon naught here. So mu naught is 1 by mu naught equal to C epsilon, C square epsilon naught. So this equation is substituted here. So the Poynting vector becomes like that. So C square epsilon naught E vector plus B vector. So the unit of Poynting vector is Weber per meter square. The Poynting vector any point gives the direction of energy transfer from that point. Okay. Then last property of the electromagnetic waves. Electromagnetic waves carries not only energy and momentum but also angular momentum. So one point is electromagnetic waves can transfer the energy and momentum. The another one point is not only that energy and momentum but also a angular momentum. So these are all the properties of electromagnetic waves, and definitely that question will come from the properties of electromagnetic waves. You can write any one or two questions and then one or 2 points. For 2 marks you can write 2 points, 3 marks you can write 3 points. Okay, like that for 5 marks you can write more than 5 marks, 5 points. Or you can write all the points. So memorize all the points. It's very important. Source of electromagnetic waves. So what is the source used to produce the electromagnetic waves? Accelerated the charges are producing the electromagnetic waves. So here it's a discharging spark that is produced by the oscillating dipole. So here the charges are accelerated. The accelerated charges are producing the electromagnetic waves. See, you know that already. The red color line and blue color line are the magnetic field and the electric field. It is a transverse wave. It is propagating through the direction of Z direction. So it's electric field and magnetic field. So these three fields are right angles to each other. All the three are. So oscillating the electric charges producing the electric field. So here that electric field and magnetic field, it's not time dependent. It's only space dependent. It is propagating the space dependent. So here that any oscillatory motion is also an accelerating motion. So the charges can oscillating about the mean position is shown in the picture. See that is oscillating between the mean position. So it is oscillated here. It can produce a wave like this. So we can define that electric field separately, because if you are considering only the electric field, that is red color line, it is like a sine wave. Suppose you are seeing that blue color line, only that blue color line, that line is also like a sine wave. So we can define that the motion of the electric field and magnetic field are the propagation of wave in the form of sine wave. So in y-axis, that electric field is propagating through the y-axis. So Ey equal to E0 sine kz minus omega t is for electric field. Like that we can indicate the magnetic field also. Vx equal to V0 sine kz minus omega t. So this is for magnetic induction. Right? So in this equation where E0 and V0 are the magnitude of the equation. See, this is a magnitude of the electric field and the magnetic field. The E0 and V0 are the magnitude of the electric field and the magnetic field, and where K are the constants and omega is the angular frequency of the two waves. Angular frequency. Finally, that K vector, suppose we are indicating that K vector shows that it is a unit vector. It will indicate the direction of electromagnetic waves. Right? In that electromagnetic waves, electric field and magnetic field, that both waves, that frequencies are equal. So it has the same frequency. Right? Here, that C equal to E0 by V0, that is magnitude of electric field by magnitude of magnetic field. So dividing the two value, you can calculate the velocity. Already we know that equation in 6th lesson, V equal to, not 6th lesson, 7th lesson, 8th lesson. C equal to V by V. Okay, do you remember that V equal to E by V? So the same thing here, that velocity P equal to E0 by V0. In any medium, ratio of E0 and V0 is equal to the speed of electromagnetic wave. In that medium, mathematically it can be written as C, that V is equal to E0 by V0 less than C. The energy of the electromagnetic waves comes from the energy of oscillating charges. So that electric field, that energy or the velocity is depending on that accelerating the charges.